Hello there, ladies and gentlemen, and today we're taking a look at Statoil regional and international offices by a lab. So we basically have the form like this. This is the finished product already now, and I want to walk you through this. And what I want to walk you through is basically this thing here. So you have this almost kind of domino stacking over top of each other, those kind of forms that go from one to the other. It has a very nice interior as well, and then it has this facade here as well, but this one we do not do today. But we were just gonna take a look at the overall form of those cubes, how they basically go from one to the other. I think it's a really interesting building, and it's definitely quite big. So what we can have here, we have basically those different stories that we can increase and decrease. Like you see, it goes up and down. And we also can obviously randomize it a little bit, and we can have several other parameters of the size, and we can also manipulate the position of those things. So stay tuned and let's get this started. Okay, perfect. So this will be just normal Grasshopper vanilla file, so just basic Grasshopper. There's no plugins needed, nothing else. So we're just gonna start very simply by making a new Grasshopper file. So what I already have here, I just created 4 rectangles like those, the rectangle, and we just create a rectangle like this. And those will be basically our main points that we define for our basically those kind of things that go from one way to the other. So I'm just drawing this out really quick here in our canvas. So we have those 4 things, right? Like that. Right? And then we have some certain points that are in here as well. Like this. And then there will be a little more, like obviously there will be a lot more of those. And then they will be basically connected from one to the other. Like that. And when they are connected, I want to basically move them up, but not all of them at once, but basically the ones here, and then the other ones up there. Basically move those up a little bit more than the other ones every time, like incrementally. Then also, if we have something like this, when there is like a thing that it's gonna be having an intersection between this, we just gonna want to delete one of those 2 things as well. So we just have non-intersecting slabs going upwards. So first of all, let's import those things, the geometry in the Rhino environment. By this, we're just doing geometry, right click it, set one geometry like this, and we're just gonna copy this 4 times, fire that 4 times. And with this, we can move them like this apart. And I want to set the geometry from this one, and set the geometry for that one, and set the geometry for this one. So now they're kind of, I will just arrange them of how they are more or less defined like this. And now we also want to give them random amounts of points. So we're just gonna do populate 2D. By the way, this is not the way most likely how they did it, but this is just the way of how interpreted at the moment. So we put in this here, then the other one here, and then this one over here. We can actually put those 2 together like this with shift click, and then we delete this one, put those one together as well. And we want to have the same amount of random points in each of those. This will be basically our, because it's a random points, we want to move upwards. This will be our basic definition of how many blocks there are. So amount of blocks. And we also want to maybe have some randomizing power here as well. So now we have those things defined, and you see they're basically merged together like this. So there are 2 branches of each 99 points. So we want to connect them basically together. We do this by doing a pull line, and if you do this now, you would see we just connect those pull lines together, but we want them to connect to the other one. So we're going to use the command flip matrix, and we're just gonna connect it to there, and now it will connect to the other point. As you see, they're going from this place to the other one. And we're going to do the same thing with our points down here. So now they're basically connected. So this will be basically our basic grid for now. Anyway, now that we have that, we want to move those things upwards in a pair of 2. So I will be just, now they're basically each in a branch of 1, but I want to flatten them to make them basically all equal. Let's say like how I select them. And I will make a new partition by partition list. And this partition will be by the size of 2, because in our example, it is also always 2 of those things. So there are 2 here. This is another one there, and actually on top of there's only 1, but we will get to that one as well. So here we have our list that we are now like partitioned in the rows of 2. So partition size. And now we want to move those upwards. So we want to basically move them upwards by like those 2 each. So we do a series that is basically half as long as the amount of blocks that we defined in the beginning, because you want to always move 2 upwards. So we're just gonna do it by division, because here we have the partition of 2, and this will be our amount of blocks here, like that. So this will be our count number, and it will also be this will be our count number for the one on top, and for the one going this way and the other one going the other way. And we're going to do the same with the other one, and we have to move it as defined as a z factor. So we're just gonna use the move command. That would be the motion and moving them upwards like this. And now you see this kind of looks weird because we need to graft this one as well. So now we have our basic lines already defined. So this looks already pretty good. And I'm wondering if there are, because right now I'm seeing there's always more than 2 or in each of the moving upwards. I'm not that sure right now, but or maybe it might be fine actually. And we want to do the same with the other one. However, we don't want, now they would be on the same size. So we want to move them just a little bit lower up to it. So this would be actually a, because right now the steps, like the step it's going on, it's just 1. And we will increase this a little bit. So this would be like our, basically the height between each of those 2 things, like this. And we will do this a little bit different. Well, we're not going to do this different, but we're going to create another series that basically will be moved up half as much in the beginning, so it will not intersect with each other. And then it's just gonna go up normally. But we will, normally you can do this by, okay, I do division, like this. Actually, let me rename this one. So height of each, and we can do this, okay, division by 2, because it will be it will be the beginning, for example, and or it will be like the starting point of it would be half a place lower or half a place higher. So it would be like division by 2. And then, oopsie, and then we can also do it negative, for example, and then it would be like this. But we actually we will be using the expressions. So we do expressions like this, and it will take a few variables. So the variable x and variable y, and we actually need to rename this to just x, and we're gonna delete this. Or we're actually might actually need that, right? No, we don't need this one. And then we can just double click on it, and we will basically do x divided by 2, and then we just put a thing around it, and we do 0 minus. So it will basically divide it by, do the same operation. So now we have a negative of the half of the height. And this we're using as the starting point for the other things, which then will be also converted to a z vector and moved upwards. Okay, and as you see, they're already like always in between there, one and the other one. Okay, now we are going to create the actual boxes itself, because at the moment we have the problem that we're just having the basic lines, but we also want to have them some thickness as well. So we're going to use the offset command, offset curve. Where do I have it? Offset curve loose. This one is a little bit better in this case. And I want to actually just hide those things, like middle mouse button and then disable preview, so we have a little more cleaner view to look at. So I'm going to use the curve here and have a certain parameter of how what width I want it to be. So I do it, whoops, wrong one, but nonetheless like this. And I want to now be connecting those points together as well. So you're gonna use endpoints like that, and those endpoints here, and I'm gonna connect them with line together. Very easy and simply like this, and like that. And then also we want to now connect those 4 parts together as well, and we're gonna do this by join curves, and we're gonna simply just drag all those pieces with shift click in there. So now you would have always in each branch 2 curves that we want to use. Good. Now we have that, so that's already pretty useful. And we can also maybe, to make this thing a little bit easier, because right now we could like duplicate it and then put it in there again, but just in case I want to revisit this later maybe, I'm putting like a geometry out here, and I want to select all of those things and actually make a cluster around it. And now we can just simply copy the cluster here, use the geometry that we had in the list here, and use the factor that we had from the series there, and we have the same amount of the same results that we wanted to have here. Without the big thing in here, we just like leave it alone. Now what we also want to do, there are some cases when I will just show you, when we extrude the curve, we will use it like extrusion in this case, and we want to extrude it basically this height, right? Yeah. There might be those things where you see here is actually overlapping, and that's not really something that we want. And even if we like change this around, we might still want to be in the position of where this doesn't happen. And actually I'm seeing right now that I used the same regions in here. Did I do this correctly? Because those regions should be going the other way. It is because I just extruded those things up here. Yeah, and we also need to extrude it just half the height that we defined here. So we're going to, we could just use this one, for example, and use it as the height in here, and this would also work really good. Yeah, I think it works pretty well. Good. And now if you obviously adjust the heights a little more to our liking, it will be, it is a little big one, it will be useful as well. I'm just gonna decrease the amount of blocks that we have here. Good. Now that we have that, I want to also, because we have those intersecting points, I want to actually just simply remove the one that is like not used in this case, or like that is intersecting. So I'm just gonna deactivate those for the moment, and I'm gonna use the under intersect and then physical multiple curves, and then gonna just drag and drop this into those things like here. And you see it just tells me if there's an intersecting curve or not. So I'm just gonna we're going to see if the list length is bigger than 0, because here you see there are no intersecting curves, thus the list length is 0. And if it is bigger than 0, we want it to not remove anything. Or if it's bigger than 0, we want it to remove just one of the pieces. Or we're gonna just choose one of the pieces. Maybe that's actually better. Actually, I want to see, because we defined the partition size. Would it still work with 3? Yeah, it actually would. Interesting, yeah. Or with 4. Anyway, so we're just gonna remove, or we're just gonna leave 1 for now out to make it just simple. So we have those points not defined, so we're gonna just use the list length commands, and we put it in the or in the index A. Well, it doesn't really matter actually where you put it, but it gives us the list length of all of those lists. And now that we will see, those lists will be either like 0 or 2, I guess, or 4 even, like in this case. So we make a under math operations larger than, we will test if the number is larger than the list length, the length of the list. So we have now defined that if this is true or this is false, and if you just copy this one over, you see in this case it is true. I actually want to have this at 0. If it's true, it is true, and if it's false, then it is false. Well, that was intelligent. Anyway, now we want to dispatch those lists out of there. So we have to actually, I don't know if this is necessary, but I want to just duplicate this list by doing a simple merge. Now you see it will just does the same thing, but it copies it one more time. And it will give us this we use as a dispatch pattern to basically sort those things out, and the list will be the curves that we had here in the beginning. And if you just deactivate those two and just put the geometry one like here, you see now it will give me only the lists that are that have an intersection in there, and the other one will be the list that there are no intersections in here. So in this case it is that one. And but we still want to take at least one of the ones that are basically imperfect and add it to it as well. So we're just going to use another dispatch, and we just leave it like this because it just takes true or false. And we're just going to take one out here as well. And as you see now, you would have 2 of the ones of the list. Let me deactivate this one. You see it just gives us 1 out there in those cases where there are actually 2. Good, and now we want to I just want to merge those 2 together. And now we have a fully functioning list like that. I'm just gonna do it like this. And I think if I just now I want to also put this in here. It's because I want to make a cluster again in this case. And do just a cluster like this. Oh, I actually want to include this one. And actually want to remove this one here. Cluster like this, very nice and tight, just one simple one, that's cool. And I just do the same with this one. I hope it will work actually, because I'm not that sure. No, I think this looks actually pretty good, right? For this one and for the other one. Good, and now the only thing we need to do, we just need to activate this thing again here. Use it for this one here as well. So now we have our very interesting things. There might be some weird stuff going on here as well, as you see. So you might need to maybe adjust the seed a little bit. So in order for it to work a little bit better or properly. You can also obviously always change those things here as well. Nice. Let me actually, I want to adjust this one a little bit more, a little bit wider, like this, and maybe that one wider as well. Good. Or actually, Okay, good. Now that we have that, we can obviously always increase those things like very, very rapidly. I just want to put this one a little bit more closer to it, like this. Okay, and also because right now they're actually open, I just want to fill them out like this. Boundary surface, and use the boundary surface of those things here, and then simply move them by the motion of the curve extrusion downwards, like that. And then you would have a very nice package of your things. And yeah, there you basically have it. And I think that's pretty useful. So yeah, there might be like some glitches and randomness to it as well, which is not really intended, in some rather provocative architectural, structural places here that are not really suitable. But yeah, maybe this one looks actually quite nice. Yeah, and then the only thing you need to do, obviously, just, you know, bake it. And if you are looking then into the Grasshopper geometry, then you would have the correct view to it. So yeah, nice. Thank you very much for watching. This was already it. Only took 22 minutes. Well, okay. Hope you learned something by it. If there's something you want to learn about or know more about, just tell me, and then we can obviously maybe I make a tutorial of it, or I can help you a little bit with it. Nice. Thank you very much for watching, and see you in the next one.